And good morning to you, fourth grade students of room 405. Yes, it's your favorite time of day. Time for Eureka Math. Eureka is a Latin phrase. It means I have found it when translated to English, and it's the official state motto of California. And what have we found, ladies and gentlemen? Well, we haven't found gold. We found something that's more valuable than that. We've found the best way to learn new math concepts, and that is more valuable than gold itself. We're going to start off with our objective. We're looking to understand and solve division problems with a remainder. Ding, 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 big word there. Using an array. Ooh, we've done that many times. And or an area model. Dun, 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 bump. All right, so that's what we'll be doing today. Let's find out how we're going to get there, okay? We'll start off with our fluency practice. Now, the fluency practice today is number sentences in an array. Well, let's see what we can do with this. I'm not going to draw too big because I want to fit them all in here. Okay, the first number sentence we're going to do is 5, and you could write this down, times 3 plus 1 equals. Let's make an array, shall we? Well, you know how much I love making arrays. So we're going to 5 times 3, and let's do circles. There's 1 3. Here's another 3. Here's another 3. Here's another 3. And it looks like we have one more group of 3s to do. Don't want to get carried away. So there's 1, 2, 3, 4, 5 groups of 3, or 5 times 3. But we have the plus 1. Let's put the plus 1 there. So what we have is 5, 10, 15, plus 1 would be what? If you said 16, you're absolutely correct. So we had 5 plus 3, 5 times 3 plus 1 equals 16. And let's do a couple of different sentences to show how this could work. What we could do, are you ready? Let's scroll down a little bit. Give yourself plenty of room. We could do 5 times 3 in parentheses, and we'll hope MathMut doesn't come bounding out of his doghouse because he heard the word parentheses. So 5 times 3 plus 1, that would equal 16. 5, 10, 15 plus 1 is 16. And let's do 3 times 5 plus 1. So 3 times 5, 5, 10, 15. Or 3 times 5, 3, 6, 9, 12, 15 plus 1 is 16. And there we have it. Now, let's do a different kind of sentence. And what we're going to do is 16 divided by 3 equals what? Let's head on back here. So we have our 16 and we're going to divide it into 3 equal groups. So I can see 1 equal group, 2 equal group, 3 equal groups. So 16 divided by 3 would be 1, 2, and 3 with a remainder of 1. So we can say 16 divided by 3 is 1, 2, 3, 4, 5. It's 3 equal groups of 5. So our quotient, remember that word quotient, is 5, but we have a remainder of 1. Let's just do one more really quickly. I think I could squeeze it in here. Barely. So we'll say 3 times 6 plus 1. Okay, well, let's do the 3 times 6 first. We don't have a lot of room to work with. So we'll do 3 times 6, okay? And we'll make that look like this. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. and 1, 2, 3, 4, 5, 6, and we'll put the additional 1 down here. So what would this equal? Well, we can count or by 6s or by 3s. We can go 3, 6, 9, 12, 15, 18, 19, 6, 12, 18, 19. So there we have it. So now let's do, if we will, 19, because we have 19 there. 19 divided by 6. What will it equal? How many equal groups of 6 do we have in our array? Well, let's take a look. We have 1 equal group of 6. We have 2 equal groups of 6. We have 3 equal groups of 6. And it looks like we have a remainder of 1. So 9 divided by 6, what is our answer? Well, let's take a look. We took the 19, we divided it by 6. 1, 2, 3, with a remainder of 1. So we can see 19 divided by 6 equals 3, and then we have the remainder of 1. Let's turn our paper. I have the master. Yours is on the back side to deal with our application problem. The application problem, a real-world look into math, meeting life. Here we go. Chandra. She printed 18 photos to put into her scrappy book. Let's circle 18. I have a feeling that number will come into play. If she can fit 4 photos on each page, I think 4 will come into play too. How many pages will she use for the photos, baby? Think about it. Well, let's think about it. Picture 18 photos that she printed out, and let's think about how many pages she will use in her scrapbook. I bet it's a lovely scrapbook. So let's start with our math right here, okay? We're going to start with a tape diagram. Uh-oh, Mr. Leggett made a big mistake. Don't do anything yet. In my haste to type this up. It shouldn't be 18. That's a little too easy. We're doing 38. 38. 3, 8. 3 10s, 8 1s. Sorry. So, we're going to do 38 of these bad boys. 38 photos. We're going to go like that, make our bracket. And we'll put 38 here, representing 38 delightful photos. Now, how many can she fit on one page? Well, if she can fit 4 photos on each page, that's how many she can fit on the page. So what we're going to do is we're going to do 4 right there. 4 photos on each page. What we don't know is how many pages she will use. So let's get busy with an array. And so we're putting 4 photos on each page, and we have 38 photos. Are we ready? Yes, Mr. Leggett, we are ready. So let's start putting photos on pages. Look, 1 page. 2 pages. 1, 2, 3, 4, 5, 6, 7, 8. 3 pages. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 pages. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4, 8, 12, 16, 20. Still got a ways to go. 4, 8, 12, 16, 20, 24. 4, 8, 12, 16, 20, 24, 28. Getting warmer. 4, 8, 12, 16, 20, 24, 28, 32. Very warm. 4, 8, 12, 16, 20, 24, 28, 32, 36. I can't put 4 more on. I got 38 pictures, so I got 2 here. 4, 8, 12, 16, 20, 24, 28, 32, 36, 37, 38 photos. So, let's see how many pages this equals. Shall we? Let's do it. Let's do it, men. 1 page. 2 pages. 3 pages. 4 pages. 5 pages, 6 pages, 7 pages, 8 pages, 9 pages. Looks like we got a remainder of 2 happening over there. So let's take a look at our remainder of 2. We're going to go like this. And I'm just going to put R2. Normally we'd use a bracket, but gosh darn it, I'm out of room. So now we could do a division sentence. The best kind of sentences in the world. So what we could say is 38 divided by 4. Remember, 38 photos, 4 to a page. What does it equal? 1, 2, 3, 4, 5, 6, 7, 8, 9, remainder 2. So the quotient equals 9, remainder equals 2. Let's kind of do a little bit of reverse. What they say is the opposite of division is multiplication. So if I did 9 right here times 4, 9 times 4, that'd be 9, 18, 27, 36 equals 36. That doesn't equal 38. Of course not. I got to add the remainder on there. 36 plus 2 equals 38. And there we have it. But yet, here's the real tricky part. You're probably thinking, well, she only needs 9 pages. But she wants to fit all the photos into her book. Each and every one. So, if she uses 9 pages, she'll have to throw those 2 away. So how many pages will she use? This is why I put think about it. Looks like she's going to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pages. Only 9 of them will have 4. This one will have to wait for another 2. So let's go ahead and write this down. Chandra will need 10 pages. Nine pages will only fit how many? 36. She will need an extra page to fit the last 2. So Chandra will need 10 pages. 9 pages will only fit 36, like we proved. So she will need an extra page to fit the 2 that we consider the remainder. That's what we consider it, the remainder. All right, what we're going to do now, and I know some of you are like, Mr. Leggett, I know how to do this, but I want you to understand what we're doing, how we're doing it, why we're doing it. So, pause this if you need to complete it, because you're going to put this in the blue bin when we're done. We're not done yet. Time to turn the page over to, oh, look at this graph paper. Isn't it beautiful? Why, it is beautiful, Mr. Leggett. Yeah, graph paper is a wonderful thing. Love and respect graph paper. That's what I always say. Well, I don't always say that. If that's all I said, I'd be a pretty boring person. Come to think of it, I am a pretty boring person. Here we go. That's not showing up too well. Mr. Leggett can waste as much scrap paper as he wants, so he's going to get busy wasting scrap paper. We're going to do 10 divided by 2. And some of you are all saying, Mr. Leggett, I know that equals 5. You know it, I know it, many of us know it. But we're going to prove it. We will show you how 10 divided by 2 does indeed equal 5. Let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Time to divide by this array into 2 groups. One group of 5. 2 groups of 5. So there we have it. Isn't that a thing of beauty? Yes, it is. So 10 divided by 2 equals 5. But I could also say, what else could you say, Mr. Leggett? I could say 2 times 5 equals 10. 2 times 5 equals 10. Or 5 times 2 equals 10. 5 times 2, yeah. So, our 2 times 5 equals 10. Get it? We got it. Now, let's prove it. We did prove this simple math equation using the array. Now we shall use the area model. Be prepared to have your mind blown. Well, maybe not. Oh, maybe. I think it's pretty fascinating. So this is how we're going to tackle our area model. Are we ready? Okay, we're going to do 2 squares. See how I did that? 1, 2. 2 squares. I'm going to put the number 2 right here. Got it? Good. Now, we're still dealing with this array up here. So we're going to do 5 across. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 down, and another 5 across. And there we have it. I'm going to put the number 5 here. Huh, I wonder how many little squares are in there. I wish the Counting Crow was here to tell us how many little squares we have in our area model. Maybe he'll come around. Oh, Counting Crow, we need your help, Counting Crow. Come here, as nobody can count like you. Ah! Ah! Here he comes, boys and girls, the Counting Crow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, thank you, Counting Crow. There are 10 in there indeed. So we could totally see this in so many ways that 10 divided by 2 does indeed give us a quotient of 5. Isn't that amazing? 10 divided by 2 is 5. Works so many ways, it's wonderful. Now, let's zoom up a little bit, and we're going to go on with another problem that will no doubt help you realize the essence of division when we're talking about a what they call a remainder. So let's get busy with that. We're going to go 11 divided by 2. We're not going to use the array right now. We're just looking at 11 divided by 2. How are we going to do this? How in the world is this going to happen? Well, I'm going to show you. We're going to start off with another area model just like this bad boy. So let's get busy with that so we can figure out 11 divided by 2. And so we're saying, Mr. Leggett, I know this, but I want you to really know it. Okay, there's our 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 2, 2, 2. 2, 2, 2, 2, 2. But Mr. Leggett looks just like the other one. It doesn't make any sense. Yes. Counting Crow already told us there's 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 times 5 is 10. 10 divided by 5 is 2. 10 divided by 2 is 5. Beautiful. It's so simple, but it's so complex. So now let's do the 11. And this little thing comes, and there is 11. So now we have a total of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's just sitting out there. Can we divide 2 into it? No! It's just there. So 11 divided by 2. What is our quotient? Just like above, our quotient remains 11 divided by 2. Quotient equals 5. But there's a slippery guy here called the remainder. What remainder do we have? 1. So 11 divided by 2 equals 5 with a remainder of 1. Hot diggity dog. Let's continue on. Friends, neighbors, and relatives. And we're going to do just a few more of these because they're so much fun, really. And let's take a look at this fantastic problem. We're going to do 16 divided by 3. Ooh, that's getting pretty hairy up there. And big numbers. 16 divided by 3. What will that equal? Well, let's start with our area model. Excuse me. Pardon me. Let's make 16 squares. So I'm dividing by 3, so I'm going to go 1, 2, 3. And I know that 3 times 5 is 15, and that's pretty close to 16. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 3 times 5. What does 3 times 5 equal? It equals 15. But we're not dealing with 15 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 divided by 5 is 3. 15 divided by 3 is 5. So nice. We need to make 16. Bum, ba-dum. Looks like a remainder to me, partner. Yeah, it does look like a remainder. So we would say 16, we're going to write that down again, divided by 3 gives us a quotient of what? 16 divided by 3, 5. But we have this little guy here. What is he? He's the remainder. Remainder 1. So 16 divided by 5 equals a quotient of 5, but a remainder of 1. Okay, we're going to try another one. let's do, what does the book tell me to do? 23 divided by a 4. Well, let's see what we got going on here. Let's make our area model. And we'll go 1, 2, 3, 4. 4 times what gets me close to 20? 4 times 4 is 1. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. So I think I'm going to do 4 times 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here we go. We have 4 times 5 equals 20, don't you know? But we're dealing with 23. Looks like I'm going to have to do some remainder work over here, boys and girls. 21, 22, and 23. So what in the world is our answer to this perplexing problem? We have 23 divided by 4. What is our quotient? Well, take a look. 20 divided by 4 is 5, isn't it? 20 divided by 4 is 5. So our quotient would be 5. But how about Senor Remainder? Remaindero. He would be 1, 2, 3. Remainder 3. So there we have it. We have 23 divided by 4 equals 5. And we have the remainder of 1, 2, and 3. Oh, I got another piece of graphy paper I'm going to waste. All right, so you guys are using front and back, of course, because you're not wasting graph paper like Mr. Leggett is. We're going to do a big old problem now, and we're going to do use up the whole paper, boys and girls. And it's going to be 38 divided by 4. So I'm going to zoom out, because we're going to do all sorts of crazy stuff. Well, not that crazy. It's Eureka math crazy. And tilt down, camera 1, perfect. All right, so 38 divided by 4. Let's do a vast array. Okay, 38 divided by 4. Remember, we don't want to go over. So we'll start off with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. Let's count by 4s. Do a little skip counting. 4, 8, 12, 16, 20, 24, 28, 32, 36, 37, 38. So there's our 38. We're breaking them up into 4 equal groups of 4. So let's get started. 1 equal group of 4. 2 equal groups of 4. 3 equal groups of 4. 4 equal groups of 4. And there's 5 equal groups. 6 equal groups. 7 equal groups. And 8 equal groups. And 9 equal groups. So there we have it. We could see that 38 divided by 4, clearly looking at this, is 1, 2, 3, 4, 5, 6, 7, 8, 9, with a remainder of, ding, ding, 2. Let's make the area model. Okay, here we go, area model. It's a big one. I'm going to use a big, thick pen. So let's go, it's 4. 1, 2, 3, 4, like that. How many across? 1, 2, 3, 4, 5, 6, 7, 8, 9 across. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 4 down, 1, 2, 3, 4, and let's meet. So there we have it. We have a 4 by 9 area model. What's the area of this area model? Try to say area 3 times fast. All right, being silly. 4 times 9. Let's count by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36. It's 36. But look, lo and behold, we have a remainder of 2. So I'm going to put these 2 little guys right here. There we have it. Let's look at this. Why, it's staring at us right in the face here. Q equals the quotient equals what? 36 divided by 4 is 9, right? but we have this remainder hanging on. So I got to acknowledge the remainder. He does not like not to be acknowledged. And the remainder equals 2. Now, let's just kind of have a little bit of fun here. And we're going to show you how to do this without graph paper, because I know that is probably on your mind. You're probably thinking, hey, Mr. Leggett, how in the world do we do this without the graph paper? Well, I'm going to show you how we do it without the graph paper. The graph paper, we're going to go to your other paper in your packet. It's a blank sheet. We call this scratch paper. So let's get busy on that. We'll go, I don't have any graphs to worry about, little cubes. I'm just going to go, and this is 38 divided by 4. I can do this, voila. Without all the little cubes, I can just go 4 times 9 is 36. Is that over 38? No, it's under 36. If I did 4 times 10, what would that be? 4 times 10, 10, 20, 30, 40. It would be over. I can't go over. Now I got to acknowledge the remainder, or he'll be upset. Acknowledge me, Mr. Leggett. Okay, I will acknowledge you, remainder. There's the other 2, okay? So we could say right here, 38 divided by 4. What is my quotient? What is my remainder? Well, you already know the remainder. Look, right there, it's 2. And you already know the quotient is 36. Isn't that beautiful? So 36 divided by 9 is 4, and 36 divided by 4 is 9. It's just incredible. I just love it. It's time for the problem set. So let's get on our problem set book. And Mr. Leggett is not going to give you the wrong problem set as he has done so many times in the past. Ay, ay, ay. Now, this will help you immensely on your homework. Immensely means a lot. So what you're going to do is your packet can go into the into the blue bin, not into the recycler, and we get out our fabulous problem set. So it is on page 47. There's the problem set. Page 47. The date today, I'm doing this last night. Haha, time traveling Mr. Leggett again. So we have 11/07/19. Oh my goodness, did somebody say problem set? Oh, it's the queen of the problem set, Yvonne. Hello, boys and girls. I'm the queen of the problem set, Yvonne. Well, Yvonne, what are you here to tell the boys and girls? Well, I'm here to tell them that they need to put the finished problem set in their binders because it will help them tremendously with their homework. They could refer to it if they forget. Yeah, you know, Mr. Leggett also posts on his website videos that are on YouTube that can help them out also. Oh, I love watching math YouTube videos, especially the ones that deal with problem sets. Well, thank you so much, Yvonne, for giving us that very important reminder. You're welcome, Mr. Leggett. Thank you, Yvonne. What a great help she is. I met Yvonne on my recent trip to Oregon. Okay, we're going to zoom in a little bit. Time to zoom in. Zoom in, camera 2. Camera 2, zoom in. All right, beautiful camera 2. All right, let's head on over here. It says, show division using an array. Show division using an area model. Oh, the best of both worlds, boys and girls. So we have 18 divided by 6. We're going to make groups of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's 6. That's 12. There's 13, 14, 15, 16, 17. And 18. Wow, looks perfect to me. We have 1 equal group of 6, we have 2 equal groups of 6, and we have 3 equal groups of 6. So our quotient must be 1, 2, 3. What's our remainder? If you said 0, you're correct. 0. Now, let's show this using the fantastic, wonderful area model. So what we're going to do is watch how it kind of flip-flops. We're going to do 3 down, 1, 2, 3. That's the quotient. And we're going to multiply it by 6. 1, 2, 3, 4, 5, 6. And there's our 6. What's 3 times 6? 18 divided by 6 is 3. So 3 times 6 must be 18. Can you show 18 divided by 6 with one rectangle? You betcha. Yes. Let's go on down to 19 divided by 6. I have a feeling we're gonna need more than one rectangle, Mr. Leggett. Oh, I have a feeling you're absolutely correct. 19 divided by 6. Let's start making equal groups of 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. What am I going to do? Oh, it goes right up there. All is well. So let's make our equal groups of 6. Count them out. 1 equal group of 6, 2 equal groups of 6, and 3 equal groups of 6. So our quotient must be 3. And what would our remainder be? 1. So let's make the same type of rectangle we made up here, because it's only 1 more than 18. So we'll do 3 down, 1, 2, 3, 6 across, 1, 2, 3, 4, 5, 6. And we can see that 3 times 6 equals 18, but we're not concerned about 18. What do we need to do? We need to add on another rectangle. To make 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Can you show 19 divided by 6 with one rectangle? No way! Explain how you show the remainder. I drew an additional rectangle onto the area model. And that's what I did. I know that 18 divided by 6 is 3, but I'm doing 19, so I had to draw an additional rectangle there. So 19 divided by 6 equals 3 with a remainder of 1. Beautiful. You can go ahead and pause right here if you need to write that down. I'm going to flip the page over. Our instructions. Solve using an array and an area model. The first one is done for you. Why, thank you so much. You find people at Eureka Math. Look how they're doing it. Little dots. 25 divided by 2. That's 2 groups of 12 with a remainder of 1. 12 divided by 2, remainder of 1. There we go, our 25 divided by 2. So this is kind of ethereal. We're thinking outside the box. Let's do 29 divided by 3, okay? So we're making groups of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So here are my groups of 3. How many groups of 3 do I have? I don't want to circle them. That'll take a long time. Let's just check them off, boys and girls. We have 3, 6, 9, 12, 15, 18, 21, 24, 27, 28, 29. One group of 3, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like my quotient is 9 and my remainder is what? These guys couldn't be put in equal groups, so my remainder equals 2. Let's take a look at the old tape diagram. So I'm dividing by 3, right? So I'm going to put my 3 here. And what did I multiply by? I multiplied by 9. 3 times 9. 3, 6, 9, 12, 15, 18, 21, 24, 27. Looks like that's not 29, so I'm going to put 28 and 29. See how that works? We could do it without the graph paper. Just got to think about it a little harder. Let's do 22 divided by 5. So we're going to make equal groups of 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right? I'm going to go ahead and circle these. 1 group of 5, 2 groups of 5, 3 groups of 5, 4 groups of 5. So it looks like my quotient would equal 4 with a remainder of what? Of 2. Of course. Of course, it's a remainder of 2. So now let's do the fabulous tape diagram. And this is where some of you might get confused, like, well, Mr. Leggett, how come we're not using this number here? We just can't think about that. Can't think about it. We just got to do the 4 and the 5, right? 4, and we're dividing by 5, and we multiplied by what? We multiplied by 4. 5 times 4 is 20. That's not 22. We got to add on the 2. And there we have it. 22 divided by 5 equals 4 with a remainder of 2. Beautiful. Uh-oh. Getting some big numbers here. Mr. Leggett, slow down. Put on the brakes. 43 divided by 4. Whoo! It's a big one. Here we go. 1, 2, 3, 4. We're going to count all the way to 43. 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. That's all I got. Looks like we're going to have remainder time again. Oh, yes. Oh, yes. But first, let's find out our quotient. I'm going to change colors here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice I didn't count the remainder. So my quotient equals 10. 4 times 10 is what? 10, 20, 30, 40. So now, let's take a look at Mr. Remainder. I'll check him off. How many in the remainder box? Aisle. 1, 2, 3. R equals 3. All right, fantabulous. We're really smoking now. Time to make the most incredible tape diagram the world has ever seen. Our area model, excuse me. So we have our divisor. The number doing the dividing is 4. And what do we multiply 4 by? We multiplied it by 10. 4 times 10, right here, see? 4 times 10 is 40. And what's our remainder? Well, it's 43, so I got to go 1, 2, and 3. So we have a total of 43. There we can see it, plain and simple. 40 divided by 10 is 4. 40 divided by 4 is 10. That's what this is in this case. And we have a remainder of 3. Remainder of 3. Goodness me, the people at Eureka must think we love to count. Ah! Well, I know you love to count, Counting Crow. Ah! But it's a lot. It's 59. Do you want to count 59? Ah! I didn't think he would. He does love to count, but that was a little too much. So let's count to 59, and we're dividing by 7. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59. So what in the world is our quotient going to be? I like saying quotient. Well, it's a very nice word. We're going to put a big Q here, equals something. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. And what's our remainder? Well, look at the remainder aisle. Only 3 of us here. We couldn't make a full group. No, you couldn't. So our remainder is 3. We'll continue on with the fabulous area model. All these math terms. So let's make this. So our divisor, the number where you're dividing by is 7. Our quotient, 8. What did that equal? Remember, we can count by 7s. 7, 14, 21, 28, 35, 42, 49, 56. And we were dividing 59. So that would be an additional 1, 2, and 3. And there we have it. Please put this problem set in your binder. You can put your math packet in the fabulous blue bin so I can review it tonight and find out who's following along and who's not, because if you are not following along in division, you will be left behind. I hate to tell you that. I hate to be so cruel and mean, but that is just the matter of fact of it. Alrighty. Oh, and go ahead and log on Zern.